Hey everyone and welcome. Today we are diving deep into one single, absolutely incredible piece of biological engineering, the humerus. Now, this isn't just any old bone. It's the central pillar of power and movement in the forelimb of so many domestic animals. We're talking about everything from your dog to a racehorse. So let's get into it and break down this blueprint of power piece by piece. So, have you ever actually stopped to wonder, what's the real secret to an animal's powerful stride? I mean, how does all that force get from the shoulder all the way down to the ground? Well, the answer isn't just about the muscles. A huge part of it is hidden in the incredible design of the very bone they attach to. All right, so here's our game plan. We're going to take a virtual tour of the humerus. We'll kick things off by seeing why it's the powerhouse of the forelimb. Then we'll explore its three main sections: the top, the middle, and the bottom. And finally, we'll connect it all to the muscles that really bring this bone to life. Okay, first up, let's get one thing straight. The humerus is so much more than just a bone. It's the critical link. It's the foundational pillar that makes pretty much all forelimb movement even possible. To put it simply, the humerus is the bone that sits right here. It connects the shoulder blade, the scapula, up top, to the two bones of the forearm, the radius and ulna, down below. It's the only bone in the upper part of the forelimb, and its main job is to handle massive amounts of weight and anchor all those muscles that create propulsion. Let's start our tour at the very top of the bone, what we call the proximal and. This is where all the action starts. It's where the humerus literally plugs into the rest of the body, forming that amazingly mobile shoulder joint. And the star of the show up here is the head. I want you to think of it like a perfectly smooth ball bearing sitting in the socket of the scapula. This beautiful rounded surface is what allows for that incredible range of motion, flexing, extending, rotating, and it all happens with almost zero friction. It's just brilliant design. Now look a little closer at this end. See all those other bumps and grooves? Those are not random decorations. The greater and lesser tubercles, they're like massive, rugged anchor points for powerful shoulder muscles. And that channel running between them, the intertubercular groove, it acts as a perfect little guide to make sure the biceps tendon stays right where it's supposed to be. And this idea right here, this is the golden rule for our entire tour. In anatomy, form always follows function. Every single bump, every ridge, every groove you see on this bone, it exists for a very specific reason. And that reason is usually to give a muscle the perfect place to attach and get leverage. Okay, moving on down to the shaft. This is the long central part of the humerus. If the top end was all about connection and mobility, the shaft is all about providing a super strong pillar for the muscles that run down the length of the limb. And a perfect example of this is the deltoid tuberosity. Notice how it's described as a roughened area. So why rough? Why not smooth? Well, think about it. The powerful deltoid muscle needs something to really grab onto. A smooth surface would be like trying to rock climb a glass wall. So the bone adapts, creating this textured patch for a super secure connection. And as we keep going down the shaft, check out the brachial groove. It's a perfect little pathway for the brachialis muscle to nestle into. And just below that, you've got the teres timus tuberosity, another vital anchor point for muscles that pull the limb backward. See, I told you, every single feature tells a story about the muscles it's built to serve. All right, we've arrived at the bottom now, the distal end. And this is where things get really clever. This whole area is intricately shaped to form the elbow, a precise hinge joint that has to be both incredibly strong and perfectly mobile at the same time. It's a real engineering challenge. Okay, let's make this super simple because these two words can be confusing. The condyle is the smooth, slick part that's inside the joint. That's the moving part of the hinge. The epicondyle is the rugged bump on the outside of the joint where the muscles grab on. So condyle is for motion, epicondyle is for power. Simple, right? So, putting it all together down here, you've got the condyle forming that hinge with the radius and ulna. On either side, you have the medial and lateral epicondyles, anchoring all the muscles that flex and extend the wrist and toes. And that deep pit, the olecranon fossa, that is a perfect little garage that the ulna bone tucks right into when the elbow is straight, creating this super stable locked position. So we've toured the entire bony blueprint. We've seen the stage, right? Now it's time to meet the actors. Let's talk about the muscles that attach to the humerus and actually make all this movement happen. They're the real movers and shakers.
And you really have to get this. A bone by itself can't do a thing. It's just a scaffold, right? A blueprint. The muscles are the engine. They're the workforce that pulls on this blueprint to create every single movement, every single action. And this slide right here, this is the ultimate cheat sheet. It connects all the dots. See the deltoideus muscle? It attaches to the deltoid tuberosity. The triceps? It pulls near the olecranon fossa. The biceps tendon runs right in its groove. This is where the blueprint meets the workers and it all just clicks into place.
Let's make this real. How does an animal straighten its leg to take a step? It's actually pretty simple. First, the big triceps brachii muscle contracts. That contraction pulls on the ulna, right at the point of the elbow. And just like a lever, boom, the elbow joint extends and the leg straightens out. It's this beautiful, direct cause and effect system. Now get ready for this. Over 70% of the humerus's surface area is dedicated to either a muscle originating from it or inserting onto it. Let that sink in for a second. That is a staggering number, and it tells you everything you need to know about this bone's main purpose. It is a machine built for movement. I just love this final analogy because it sums it all up perfectly. If the skeleton is all the physical hardware, the levers, the struts, the joints, then the muscular system is the software. It's the code that tells all that hardware exactly what to do, when to do it, and with how much force. So, to wrap this all up, I want to leave you with a final thought. Now that you understand this incredibly close relationship between a bone's shape and its muscular function, how do you think the humerus of an animal built for flight, like a bird, might be different from one built for powerful digging, like a mole? The answer lies in everything we've just explored. Something to think about, right? Thanks so much for joining me.